Okay, here we go. We've got a question about point masses and equipotential lines. Now, if you are an SL student, you will probably not know what equipotential lines are, and so therefore you should move on from this question. HL, please try it, and when you're ready to see an explanation, press play. Okay, I really like this question because it's a good application of some very rarely used physics, which is the relationship of the field strength to the potential. Put simply, when we're calculating field strengths, we can use this relation, which is that the field strength is equal to minus the potential gradient. And I like using it in this situation because we've got an idea of the field, which is horizontal here. We've got our equipotential lines. Remember, equipotential lines cut our field lines at 90 degrees, and so therefore our field lines are going to be kind of along these 100 kilometer arrows as well. Now, we know all we have to do here is think about the values. What we're going to do is we're going to think about delta V and going from this point here to this point here. So from left to right. Okay, I've got my potentials. Okay, well, we've got final, take away initial. I'm going to do take minus 1, minus 5. Sorry, bracket needs to be put in here. Okay, times 10 to the 6 because we're doing with megajoules. And because we're increasing x, we're going from 0 effectively to 200 kilometers. That's 200 times 10 to the 3. Now, we're going to put those numbers in, and remembering our minus sign at the front, we have minus 1 take away minus 5, that's 1 plus, minus 1 plus 5, that's a 4 times 10 to the 6, and that's divided by 200 times 10 to the 3, which then gives us an answer of minus 20 meters per second squared. Now, this is where the direction was important. We were, in this case, always from left to right, and so therefore, you can see we've got a minus sign. Okay, that therefore assumes that right is positive, left is negative, which is why the answer here is to the left. Another way of thinking about this would be is that our gravitational field lines always point towards a lower potential. If you think about going towards the surface of the Earth, the surface has a negative potential, infinity has a 0 potential, and so therefore anytime you fall down that potential well, your field lines are going to point towards lower potentials. So therefore your gravity in this case is acting to the left.